Katie Rydell, and I'm going to tell you about limits. Limits are not fun, but they're a very important part of calculus. First, you kind of need to know what a limit is. A limit is what you're approaching in a function. See, right here, I put a point at my limit, which is 3, 2. It's not just a random point I put on there. But anyways, when you find limits, you don't want to know what the 2 is. You just want to know what it's approaching, like the y value it's approaching at that point. You don't know what the point is. It is at that point. Because this right here, this doesn't matter. You don't care what's going on right there. You just care what's approaching. So, because if at that point anything could be happening. It could be way up here. It could be, I don't know, weird. But anyways, so you don't really care what happened at that point. There's also some other things that can go on with limits. You can have like an issue where your graph's really weird and it goes like this, or just like it stops here and then it starts down here. And there's this big break right there. That's where your limit does not exist, unless you're approaching it from the right or the left. You have to have this notation for it to work. But if it's with the normal notation, which is like x approaches c, it does not exist. You can solve limits a couple ways. You can make a chart where it goes down to like 0.0001 and find the y value. Or you can just look at the graph, which is what I usually do because that part's tedious. Or else we have some shortcuts, and you can do it mathematically. Here are some of the shortcuts. If it's just like a constant number, it equals that constant number. If it's an x, you plug in the c, and it equals the c. If it's to the nth, you pick the c and you put it to the nth, whatever the heck that might be. If it's and sometimes you have to take one function times another, or add it or subtract it from another. So here's some examples of how that would work out. See, if limit of f of x equals L, limit of g of x equals k. So if you are taking b times f of x, it'd be b times L. That's how you'd figure it out. If you are taking f of x plus or minus g, it'd be L plus or minus k. If you're taking f of x times g of x, it equals k times L. If you're taking f of x divided by g of x, it equals L divided by k, and so on and so forth, as you can see. There's another part of limits. Well, there's another shortcut over here. It has to do with finding limits at infinity. That's not very fun either. Basically, it's difficult. But anyways, you start out with c over x equals r. You want to get your equation into something like this, because then it makes it a lot easier. So here's my equation that I'm starting with. First, I wanted to get simplified a little bit, so that's a little easier, not so big of. So I took it all and divided by x to the third. So that leaves you with 5 minus 3 over x plus 10 over x to the third. So with this equation, this is supposed to be equal to 0. With this equation, you take this. See, this is just 5 because there's nothing underneath this, so that just equals to 5. 3 over x, that's like 3 over x to the 1, which fits this format, means that equals to 0. That's equal to 0. This fits the same format as well, so that also equals 0. And when you add it all together, it equals 5. So the limit of x which approaches infinity equals 5. Another thing you can find with limits is your derivative, and that's back over here. There's an equation that you can use to find your derivative, which is basically the slope of the function you're using. So limit of h as it approaches 0 equals f of x plus h minus f of x over h, which is basically the change in x's over the change in in y's. So that's your slope form anyway. So I use this equation, x equals x over x squared. So I plug that in, and it just turns out like this. X plus h squared minus x over 2 divided by h. So then you simplify it, and it ends up being x squared plus 2xh plus h squared minus x squared over h. So then you simplify that even further, and you get 2xh plus h squared over h. So then you take out that h, and you get 2x plus h, plug in the h, which is 0, and you get 2x, and that's your limit. Also, another thing you need to know about finding limits is you just want to simplify the equation to the point where you can plug in your limit, which is the c, your constant limit. So as long as you can get it to that point, you can solve it. If you can't, then I guess it's undefined. That's all I gotta say.